Assalamualaikum and good day all. Today I would like to explain about new subtopic in the chapter 2 about the magnetic refrigeration system. So this one is one of other type of a refrigeration system. Uh, Last time we already discussed about the vapor refrigeration and also absorber refrigeration. Now we go to about the magnetic refrigeration. Uh, we will discuss about the application, how the refrigeration work, and then the application benefit, and also disadvantage of the magnetic refrigeration itself. So what is the magnetic refrigeration itself? So actually, this refrigeration is developed by using cooling technology based on the magnetocaloric effect. So this caloric will be produce the thermal in the same time also uh, cooling temperature. So how this will work, we will discuss later on. And the second one, the magnetocaloric effect, or we call in the short form MCE, is a magnetothermodynamic phenomenon in which a change in the temperature of suitable material or refrigerant is caused by exposing the material to changing magnetic field. So actually, the magnetic refrigeration also need the refrigeration or medium to transfer thermal within the cooling or in the hot condition. So still have heat exchanger uh, or coil to uh, to try to utilize the temperature, or we rejected the temperature with a high temperature to the environment. Okay, magnetic refrigeration process have the also 4 steps. This is similar in the conventional refrigeration system. We also have 4 steps because of we still use refrigerant to transfer the thermal. So that's why we have a similar step with the conventional refrigeration system. So the first one is adiabatic magnetization, and the second one isomagnetic enthalpic, and the third one adiabatic demagnetization, and the last one isomagnetic entropic transfer. So how will this process will work in the one cycle of the magnetic refrigeration? I will inform you detail in next slide. Okay, as we know, the magnetization is influenced by magnetic field. So electric field, or sometimes we known in the H, electric field, so surround the power of electromagnetic field. So we influence the surround around the magnetic between the north and south of the magnetic. So within this pole will be influenced by magnetic field. So the refrigerant will be put between this pole, and then will be processing in the magnetization. So in this stage, the temperature will be increased because influenced by the magnetic field. So what happened? The refrigerant will be processed into the vaporized. Yeah, you can see here in the graph. And then after that, when we release the magnetic effect, influence, or we try to uh, remove the coordinate or position of uh, refrigerant, because this refrigerant will be input in one container in the adiabatic system, adiabatic system. Adiabatic, we know as a closed system. The mass cannot cross the boundary, but the temperature can influence inside the system. So we call the adiabatic. So what happens if the refrigerant influenced by magnetic? So the temperature will be increased inside of the uh, container. And then what happen? Uh, will be increase also the pressure. So the flow will be starting in the refrigerant system. So when we try to remove the container from the electric field, so the temperature suddenly uh, in the cooling system. So this cooling system, the refrigerant will be changed into the liquid also, back to the liquid phase system. And then because of we have already pressure inside of the cycle, so the flow will be work. Yeah? So after that, again, after change into the liquid system, and then again the magnetization will be work again, and then repeat again. So we call this process in the cycle system. So what happened actually uh, in the refrigerant itself? What happened actually when we try to give the magnetization? So actually the position before the magnetic dipole will be randomly position. So when the effect by the magnetic field, so the position will be well distribution in one pattern like this, like the figure. So the temperature also change because this process. So if we compare with the conventional refrigeration, actually we already remove the pump in the refrigeration system. So that's why we have some advantage in this condition, because we can make a more efficient compared to conventional refrigeration. Okay, if we compare from the figure, so in the step one, in the magnetic refrigeration, we try to magnetize the container with the refrigerant inside. And then we compare into the conventional. Is this one is pump process. We try to compress the pump, and then in the second stage, after we magnetize, so the temperature will increase, and then we try to remove the heat by remove the condition of container from the magnetic field influence. So in the conventional, we try to flow the refrigerant to the process, to the next process. So in this case, we are already remove the pump function in the magnetic. So the flow already carry out by the increase the temperature. As we know, by increase the temperature, the pressure will be will be increased. So the flow will be happen inside the cycle. And then after that, after we remove the container of refrigerant from the magnetic field, so the refrigerant back into the initial temperature. So back to low of temperature. So what happened? We try to utilize this temperature to refrigeration system. Okay. So what is the adiabatic magnetization process? As I mentioned before, because adiabatic is a closed system, but only temperature can influence inside to the system. So we try to increase the temperature without other energy from the outside, so we can cut the cost to give heat inside of the system. So we just use the magnetic field inside the uh, adiabatic system. So what happened inside? The temperature will be increased from the T plus to delta T AD. AD is mean adiabatic temperature variation. So now we have two temperature. The first initial T and the second one is adiabatic process. Yeah. And then the process in the magnetic refrigeration is isomagnetic entropic transfer. Either the heat can then be removed by a fluid like water or helium. So actually, we can use a refrigerant in the magnetic like the helium or water, for example. So we can use this one in the magnetic refrigerator. And then we, in the isomagnetic, we try to add the heat inside the system. Magnetic field held constant to prevent the dipoles from the reabsorbing the heat. As I mentioned before, one figure, then how to dipole arrangement inside of the uh, refrigerant system. So maybe after influence by magnetic field, so will be arranged in the well arrangement, very good arrangement, because already spread by dipole, so influenced by north and south. So maybe some will be to one direction to the north, one to the south. And then after that, sufficient cooling magnetic material and coolant are separated. So as we know, the refrigerant already some will be changed into the vapor, some still in the condition of cooling, because we use the one cycle, so one part already cool, one part already in the high thermal, because this differentiate will be produce different pressure. If we have two different pressure, what happen? The flow will be occur. So if we have a lower pressure, so the high pressure will be removed to the part in the low pressure. So it's like the flow of nature of water. They simplify like a flow of nature from the high to the low. So like that. And then other process adiabatic demagnetization. So after the cycle already occur. So we try the high temperature to be changed again to low by release the um, magnetic field from the container. Yeah. So after that, again, we have transfer this isomagnetic enthalpy, because we are already cooling this temperature, because we are already released the magnetic fluence, so the temperature already cool. So we try to use this condition to utilize this temperature by coil, to release to the room. Okay, that's all the four process of cycle in the magnetic refrigerator system, refrigeration system. Now we go to the what components required for the construction. So the first one, we need the magnets. So of course, we try to uh, create magnetic refrigerator or refrigeration. Of course, we need the magnets. The magnets are the main functioning element of magnetic refrigeration. Magnet provide the magnetic field to the material so that they can lose or gain the heat to surrounding and from the space to be cool respectively. So we need the magnet. So what magnet will we use? Maybe high magnet field, very high magnet field. Only certain uh, material have this uh, power of electric magnetic field. Yeah. So this is a nature magnet, condition. And the second one, hot heat exchanger. So we need coil to transfer uh, hot temperature to the environment. So the hot heat exchanger absorbs the heat from the material used and give to the surrounding. It makes the transfer of heat much effective. And then another is cold heat exchanger, also coil, but is one, this part is for the cold part. Yeah. So we try to utilize to our room or inside the building. Yeah. The cold heat exchanger absorbs the heat from the space to be cooled and gives it to magnetic material. It helps to make the absorption of heat effective. And then the uh, other component is drive. Drive provides the right rotation to the heat to right handle it due to this heat flow in the right desired direction. So actually, we need drive the magnetic, yeah, into the uh, container, refrigerant container. So if we need the container to increase the temperature, the draft will be, we will go to the side of container. So the container will be influenced by magnetic field. So after that, in certain time, already measure how many times to be released the hot part of the container. The drive will be removed to other part of container. So should be like that. So like the dynamo or the electrical motor. We go to one pole to other pole to other pole. So maybe we design more than two of container inside of the what we call maybe reactor of refrigeration system. So we need the draft condition. And then magnetocoloric wheel. So it forms the structure of the whole device. It joins both the two magnet to work properly. So we need wheel to meet to dipole within the north and the south. Okay, we need that. So the wheel will be always uh, in the one position, fixed like the electric motor. One is a rotor and one is the motor, right? So function will be go to the other pole, other pole, other pole. One will be static, stator, and then other is motor. Okay, this one is an example of condition how we utilize the magnetic field. Yeah, this one the wheel, so will be function as a rotor or motor, and then other part container will be function like stator. Uh, so when the magnetic influence the container, so the temperature will be increased. Where the magnetized, so the temperature will be reduced. So the application, so we can design how refrigerator system by utilize the magnetic field system. We can use the rotary. So every maybe we can create more than one or one pole position of the magnetized system. So the Cry-Fuel system group is developing an AMR refrigerator for the purpose of liquefying natural gas. A rotary configuration is used to move magnetic material into and out a superconducting magnet. This technology can also be extended to the liquefaction of hydrogen. So we can use hydrogen. So actually, the magnetic refrigeration is a new technology in the refrigerator system. So maybe still to find out, still in the research to give the what we call very good performance. Performance. We try to carry out what parameter, what design still. So maybe we can apply in the house refrigeration system and maybe in the building, heat building, and then maybe in the medicine system we keep the storage of the what we call medicine storage, and then food industry, and also maybe electronic. So what I heard, uh, we are already applying in the processor cooling system. We use the magnetic refrigeration system. Maybe sometime what I saw before. So the refrigeration liquid is developed outside in the CPU. So the CPU is maybe the design in the open system, and then we can see the refrigeration moving uh, into the processor, because we make the pipe transparent so you can see the flow of the refrigeration into the through the processor system. So now we go to maybe almost finish uh, in this subtopic. We go to advantages of the refrigeration. The first one, of course, high efficiency, because I already removed the pump system by adiabatic system in the inside of the cycle. So the magnetic calorie effect is highly reversible. The thermodynamic efficiency of the magnetic refrigeration is high. It is somewhat 50% more than the conventional cycle. So actually, in the conventional refrigerator, we use the high work in the pump. So when we remove the pump function, of course, we have higher in the efficiency, and then reduce operating costs, yeah, because some part already eliminated. Then compactness, this one is simple, very small, because we need only a reactor, magnetic reactor. Then reliability, yeah, because we don't use the armness of refrigeration. And low capital cost. The technique will reduce the cost of the most efficient part component is not there, and then hence the initial low capital cost of the equipment. And then what these advantages? The initial investment is more as compared with conventional refrigeration. So the investment, because we use very rare of mineral to create the nature of high magnetic field. So this one is very rare in the world. So the initial investment, we need high cost. The money-to-calorie material are rare earth material, and then availability also adds up and disadvantage in the magnetic refrigeration. And then permanent magnetic have limited field strength, electromagnetic, and superconducting magnet are too expensive or expensive. Temperature change are limited, multi-stage machine, loss efficiency, then moving machine need high precision to avoid magnetic field with the reduction due to gap in the magnet and the magnetic calorie material. So actually, magnetic calorie material, we have a gap because we keep in the one container. So electric fields will be have high precision to create the magnetic inside of the container. So conclusion, this one maybe it's a last part for this topic. The first one, our conclusion is, it is a technology that has proved to be environmentally safe, of course. And then the second one, in order to make the magnetic refrigerator commercially viable, scientists need to know how to achieve larger temperature swing and also permanent magnetic, which can produce strong magnetic field of order 10 Tesla. So it should be create in 10 Tesla of a magnetic field. So maybe we need a special material. There are still some thermal and magnetic hysteresis problem to be solved. The material, the ICD, the MCA, FCE will become really useful. Magnetic material available for room temperature magnetic refrigeration are mainly. This one is gadolinium. Gadolinium is we produce gadolinium is a mineral or material for high magnetic field. This one is nature material because permanent of magnetic we can get inside in the gadolinium. Excellent behavior of refrigeration and heat transfer is required. It can be used household refrigerator, central cooling system, room air conditioner, and supermarket refrigeration. This technology must be universalized worldwide. Okay, I think that's all for our class today. So I hope we can do the task to consider your attendance. Please check the ULERN. Okay, that's all. Thank you. Assalamualaikum and good day.